Okay, I thought we'd do a little Python to go with the floating point arithmetic video. You thought, well, that was long enough as it was. Why do we need more? But let's just kind of see this. What I did now, I needed to import some libraries. The textbook doesn't really get into that for quite some time. We may get into the import math part because we may want to do some math more than just the usual arithmetic. At any rate, I needed to import those to do these other things like this, finding the minimum float. So this is system float info minimum. And so, this in some way is the smallest floating point number in Python. However, what we'll see, so I printed that number out, and then I took that number minus half that number, and what we'll see is it did it just fine. And so I have gotten underflow errors with Python, I believe. I'm pretty sure I have. It just doesn't seem to quite work the way it does with some other languages. Then here, I just printed a blank line so we could see where we did things. And here I took 1 plus 1 over 100 plus 1 over 100 squared, or 10,000 plus 1 over a million, or 10 to the 6th. So I just kept going up by powers of 2, 10 to the 2, and up to 1 over 10 to the 16th. And I added them from biggest to smallest, and then smallest to biggest, and printed out those two numbers. And you would think, right, we'll get the same answer, but we don't. And then I solved this quadratic formula here, or quadratic equation, using the quadratic formula. You can kind of look by inspection, once you know what the answers are, that yeah, those would be the answers. So if I put in here 10 to the 17th, what will happen is I'll get 10 to the 17th squared. Then x is 10 to the 17th, so I'll get a minus 10 to the 17th squared, so those will cancel. And I'll get a 1 times 10 to the 17th, but a negative, and then plus 10 to the 17th, so I get 0. And if I put in 1, I'll get a 1 minus this 1, because x is 1. So that'll be 0, and then a minus 10 to the 17th plus 10 to the 17th, I get 0. So those are the answers. So here B is 10 to the 17th, 1e17, negative 1e17, and then minus 1, because the minus goes through everything. And C was 10 to the 17th. So here I print out minus B plus, that's where I had to use the math thing, the square root of B squared minus 4c. Now a is 1, so I didn't bother with a 1 in there. And so there's the usual quadratic formula. Now b was negative, so I did the minus b and then plus. And that's x1. And then x2, I did the usual minus b minus, and did it that way. But then I also use that formula where we use 1 over x instead of the x, and turn things upside down, and I have my 2c divided by that same thing that I have up here. And so again, since b is negative, I get a positive plus another positive. And we'll come down and look at the difference. So first, so there was my smallest number, 2 times 10 to the negative 308, but when I took half of it and subtracted and so forth, I got half of it. I mean, so it didn't give me an underflow error or anything like that. I could keep trying, but it just the documentation for Python 3 seems to say there's not really a biggest or a smallest. Now at some point that can't be true, because if I go to I only have 3 base 10 digits here. I don't think it keeps going, but I don't know. I haven't tried to do like 4 base 10 digits on the exponent. So you could mess around with that, see if it'll take it. But the documentation seems to be saying it might. Okay, now here are the sums. So I added from biggest to smallest, and then here I added smallest to biggest, and you notice it's just a little bit bigger number, because what happened here was this last term up here, that 10 to the negative 16th, 10 to the negative 16th, didn't get added on. So this is the answer of adding 1 to the 10 to the negative 14th. I get the same answer both ways. If I, so let's just check that, right? If I get rid of this, and I also get rid of this one. Now, look at the number here. It's alternating zeros and ones and ends in a 1 there, right under that set of 2 zeros. If I run those cells again, notice I get the same answer. So what happened was this part was not added when I added biggest to smallest, but it was added when I added smallest to biggest. And so you have to go to pretty small numbers and so forth, but we do when we are doing these algorithms and so forth. Many applications would need to go to pretty small numbers for things that they're doing. And then finally, as you look at the answers for x1 and x2 for this quadratic equation that we did, the first answer, great, 10 to the 17th, just like we said it should be, 10 to the 17th. But now look, if we just use the regular implementation here of the quadratic formula, it says the other one's 0, and that's not true. I mean, we know it's not true because c is not equal to 0. It's far from 0. It's 10 to the 17th. Whereas if we use this formulation, we get the right answer of 1. And so you see, even when you go out to huge numbers of digits and all this kind of stuff, these things still matter because numbers can get different enough in size, or if you're adding enough numbers, you will get different enough in size and that sort of thing. So these things do matter, and so I wanted to make sure you saw that with the floating point numbers, that they mimic our real numbers, but they are not our real numbers. You have to be careful about how you go about doing the arithmetic at times. Other times you don't have to be so careful, but at times you have to be very careful about doing the arithmetic because you could get very grievous errors like that if you are not careful. Okay, well there, I think that does it for kind of that supplement, the Python supplement to the floating point.